Okay. All right. So what do we mean when we say double angle? All right. So first off, let's start with something super basic. All right. So let's start with something like this. Sine of 30 degrees, right? So what do we think? Sine of 30 degrees. What did we say that was equal to always? Root 3 over 2 or 1/2? 1/2, right? Because that's the small angle, so it's 1/2. So now, check out two things I could do to this. First, what if I have 2 times sine of 30 degrees, right? What is that? That's 2 times 1/2. Is that right? So that'll be a 1. So that is 2 times sine of theta. Versus, what if I did sine of 2 times 30 degrees? Is that the same as what I did in the red? That's not the same, because this will give me sine of 60 degrees. And how much is that? Root 3 over 2. Okay? So do you see that there are two different operations here? One is 2 times sine of theta, where you just find the sine and you double it. Or you have sine of 2 theta. In that case, the entire angle will change from like 30 degrees to 60 degrees. So we're looking at a completely different part of the unit circle. All right? Same thing like if you had, sine of 45 degrees. Now if you did sine of 2 times 45 degrees, what is that? Sine of 90, right? So do you see how you start from one part of the unit circle, and then sine of 2 times the angle is an entire portion of the unit circle altogether? So that's what we're gonna be focusing on today. These are called double angle identities, and this is when we have sine of 2 theta. Right? We're doubling the angle, so we're moving to a different part of the unit circle. All right. How do you find sine of 2 theta? Right? You have identities, of course. So let's just look at sine of 2 theta. The recipe for that calls for 2 times sine of theta times cosine of theta. So once you have the ingredients, all you have to do is plug it in. Now, if you look for cosine of 2 theta, there are 3 versions, 3 varieties. And you can use any one of them depending on what you have or the mood that you're in that particular day, all right? So they're all equally usable, okay? And then you have tangent of 2 theta, and we'll get to tangent of 2 theta in a minute. All right, so without further ado, let's just jump into one, okay? Let's see what you have here. You have sine of theta is 3 over 4. So this is what you're given. On the interval 0 to pi, you need to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta. All right? Okay, so let's start with the first one. For sine of 2 theta, what do I need? Sine of theta, cosine of theta. Any way I can find cosine of theta? I have sine, I need cosine. How would I find? Yeah.
Sine squared.
That one, right? Okay, so I'm given sine. I need cosine of theta, right? So how do we find it? Well, we find it using Pythagorean identity. All right? Sine squared theta plus cosine squared theta equals 1. All right, what's sine squared theta? That's going to be 3 over 4 squared plus cosine squared theta equals 1. Good review, right? From before, 9 over 16 plus cosine squared theta equals 1. So what's cosine squared theta? 1 minus 9 over 16. And if that's 16 over 16, then that's, when we subtract, we get 7 over 16. And if I take a square root, I get plus or minus root 7 over 4. Okay. Now, plus or minus, you should have been given information here on how to, how to choose the plus or the minus. So here, I'm just going to add in to assume we in quadrant 1. In other problems, you'll be given information. All right, so in quadrant 1, we're going to take the positive, right? So cosine of theta is positive root 7 over 4. All right, now what? Now, huh?
2 times.
Right. So now I can say, all right, sine of 2 theta is 2 sine of theta cosine of theta. Okay, so look, differentiate here, right? This is cosine of single theta that goes in here. All right, so differentiate between the two. So sine of 2 theta is going to be 2 times. What's sine of theta? We were given that. 3 over 4. What's cosine of theta? We just found it to be root 7 over 4. Okay? Yeah. I can simplify those. So this is a 2. So we have 3 over 2 times root 7 over 4. And then that's 3 root 7 over 8. Right? That's sine of 2 theta. Okay, what about cosine? For cosine, you have 3 versions. Which one of them do you think we should use? It's really, like, totally up to you. Which one do you want to use? 1, 2, or 3? 2. Thank you. Cosine of 2 theta. That's my favorite one, actually. I don't know why. It makes no difference. So 2 times cosine theta squared. All right, so cosine theta is the one we just found here, root 7 over 4. Minus 1. And then, like, go slow. Don't rush through this. 2 times 7 over 16. Right? Why 7? This square belongs to the root 7. And then it makes the square root go away. And the 2, and it also belongs to the 4. Minus 1. So how much is that? 14 over 16. Minus 1. Can I simplify 14 over 7? Sure.
14 over 6.
Thank you. 7 over 8 minus 1. Okay, now I have 7 over 8 minus 8 over 8. That's negative 1 over 8. So cosine of 2 theta is negative 1 over 8. Okay, that much was fun. Now what about the tangent? Check out the formula for the tangent. That doesn't look like it's too much fun. Do we know another way to relate sine and cosine and tangent? Sine over cosine is tangent, right? Now, sine theta over cosine theta is tangent theta. Sine 2 theta over cosine 2 theta is tangent 2 theta. So I can use that for tangent. Instead of using that nasty formula up there, I can just say tangent of 2 theta is sine of 2 theta over cosine of 2 theta. If you want to use this relationship, all the thetas need to look the same. 2 theta, 2 theta, 2 theta. So you can't have a 2 theta here and then a single theta anywhere else. Okay? So now, what was sine of 2 theta? 3 root 7 over 8. And then negative 1 over 8. The 8's go away. So what do I have left upstairs? Just 3 root 7. And downstairs, negative 1. So tangent of 2 theta is negative 3 root 7. Okay, so we found sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Make sense? A little? Too much? Okay. Okay, so here is one where we have to solve an equation, right? But there is a problem here. There is a huge problem in that, take a look at this. Here you have cosine of 2 theta, and here you have cosine of single theta, right? You can't have one of each in an equation. It has to be homogeneous, so either all 2 thetas or all single theta. And we like working with single thetas, so what we're going to do is we're going to replace this with something with just a cosine of single theta, right? So now go back to your identities. Is there one where we can replace cosine of 2 theta with something else? Well, I have 3 varieties here, right? So now you have to choose which one of these is best suited for our needs. Well, this one has a sign in there, and I don't want a sign because the rest of my equation is cosine, right? So that means the best one to choose is that middle one, because that middle one only has cosines in there. So I'm going to use the identity that says cosine 2 theta is equal to 2 cosine squared theta minus 1, right? Does everybody see where that came from? Okay, again, the reason why I like this is it replaces cosine of 2 theta with another cosine, and B, now it's a single theta, right? So what we're going to do is just for this one, I'm going to put in 2 cosine squared theta minus 1. Everybody okay with why I did that? Okay. Minus cosine theta equal to 2. Okay, so now look at what we've got. Yeah, it looks a little bit more complicated. That's because we haven't really worked with it yet. But look at what we have. You have cosine, cosine, single theta, which is what I want. Okay, now let's see what I could clean up here. I have 2 cosine squared theta. And can I just swap the order of the purple and the red here and just say negative cosine theta negative 1 equals 2? I haven't done any math. I just rearranged it. And now anytime I have an equation, I want to set everything equal to 0. So I'm going to subtract 2. And here I get 2 cosine squared theta minus cosine theta minus 3 equals 0. Yeah. You can factor now, right? Remember how we factored? Okay, so what's our handy dandy way of factoring? Multiply this to that, and I get cosine squared theta minus cosine minus 6 equals 0. So now, I need 2 numbers. I have cosine theta, cosine theta. I need 2 numbers that multiply to negative 6 and add to negative 1. Any ideas? Right. And now I had taken out a 2, so I'm going to put that back. That means here I get 2 cosine theta minus 3. Cosine theta plus 1 equals 0. Okay, now look, something times something else equals 0. I can totally set each one of those equal to 0. So 2 cosine theta equals 3. Oh, hang on, let me do it this way. Cosine theta minus 3 equals 0. Cosine theta plus 1 equals 0. 2 cosine theta equals 3. Cosine theta equals 3 over 2. What's up with that? Can we do that? What's 3 over 2? How much is it worth? I mean, how much is it equal to? 3 over 2? Is that 1.5? Can cosine equal to something greater than a 1? No. So that doesn't work. Here, cosine theta equals negative 1. That we could do, right? So what's theta? Where is cosine equal to negative 1? At pi. And so that's it. Theta is pi. All right? And I'll stop here for today.